we'll head over to our next presentation. And our next presenter, Edward De Jong. Welcome to Func Prog Sweden, Edward.
Thank you for having me. Can you hear me all right?
We hear you all right. Warm welcome, Edward.
Great. I'm here in Cairo for my son's wedding, and we had a power cut at 6 p.m., so I was panicked for a while. They do that because people come home from work and turn on their air conditioners and blow the fuses of the entire city. Anyway, thank you for having me. I'm here to talk about the Beads language. Beads language is a very odd language in terms of the landscape. If you look at most languages in their actual syntax and specification, they do not actually draw or handle events in the language itself. They're done through libraries, which are inevitably extremely dependent on the operating system. Other languages have some drawing and events built in, you know, like ActionScript 3, which was what was in Adobe Flash. APL had some graphics, Dart and Flutter.
Sorry to interrupt, Edward,
yes.
But do you want to make your slides into full screen? You can share them like this if you like. I just want to ask you if you want
No, you're right. That would be good. Okay, so most languages don't driving drawing, all right? So I've been making graphical interactive software for 25 years. And the problem now is that Google controls the web, and they have decided that we are going to program in HTML and JavaScript and CSS together, and maybe add some tools on top of that. And that is the only way into the browser. You know, the browser doesn't support any other. You can talk about WebAssembly, but it does not have the ability to draw yet, and it does not have control of the browser at all, really. So you've got to generate something in JavaScript. And frankly, and never in history did people have to write in 3 different languages at once in some side of file. Sometimes it's 4 languages. So I just couldn't stand it. So my goal was to replace that entire stack with a single language. And I want pixel precision, and I want it to be interactive, and I want it to be super robust and reliable, and I want it to be brief. I want it to be a shorthand notation for professional programmers. But I still want it to be able to be understood by other people. So I don't want it to be cryptic. I'm not going to use a lot of any one of the 600 Unicode arrows and symbols that you would have to learn just like Chinese and memorize. So I wanted to maximize 5 characteristics at once. It has to be graphical and simple, robust, concise, and maintainable. And that is a very difficult set of simultaneous constraints because if you want to be graphical, usually it gets complicated. And if it's maintainable, it may not be that concise. So there's a lot of compromises in here, and you will be the judge of whether or not I achieved these 5 things. This is a free product. It's an indie effort. It's in a commercially usable state. I'll show you some examples in a minute of commercial use of it. It spits out JavaScript in one file. So you have one HTML file, which is 99% JavaScript. And then for the server side, you just generate it as a node, as a .mjs file, which is the node, the suffix for a node file, which is just JavaScript running on the node.js interpreter, which compiles it just in time for the server. It's particularly good at client server because you can write in the same language for both sides. This is it's a dumb compiler. There's no fancy autocorrect or suggestions or anything like that, but it is at least fast. So you can say compile and it's under a second, and you don't need a make system. The way you code in this language is a little different. You're writing in small little chunks of code, and you have hundreds of these little blocks of code, and they're basically formed into a hierarchy that matches the structure of the screen you're trying to draw. And each block of code has a prefix in front of it saying what kind of work is that code going to do. Because if it's a drawing block, it's going to have an implied graphical context variable. And if it's an event handling block and tracking events, it's going to have the block it drew, and it's going to have an event handler. It's going to have an event record. And then if it's a calculation block, it can only calculate and is not permitted to draw. So you have those types of blocks. So it's you're tagging every chunk of code as to its purpose. And the reason for that is, well, I'll get into that later. One of the problems when you get into large graphical interactive products is that the event handling code is nowhere near the code that draws. And so when you are given a big complex product to maintain, somebody says, here, take over this product, and it's 10,000 lines of code, and someone says, it doesn't respond right when I click over here, it is extremely difficult to know where event tracking is going on, especially if you're dynamically adding listeners. You have to figure out who added that listener and where was that code that did that. So instead, in our system, in beads, you put the tracking code right after you draw that area. And every time you draw a rectangle on the screen, you own the events for that rectangle, and the event handler for that rectangle of screen space is immediately after the drawing code. And that forces you to keep your code in a sensible, maintainable structure. I wanted it to be robust. And one thing that I admire about spreadsheets, and I think it's one of their superpowers and why Excel is so beloved by business people. It may not be liked by programmers, but there are literally a zillion people using Excel spreadsheets. And why do they like it? They like it because it has closed arithmetic. That's one of the things that's special about Excel, is that if you have an undefined variable and you multiply it by 2, it propagates the undefined. Or if you have an error condition and you multiply it by 2, it still is an error condition. And so errors propagate through the system, but it never crashes, you see? And obviously there's a trade-off here. You're doing error checking on every computation. It's not going to be used for matrix manipulation or machine learning applications. One of the things that I think Excel forgot to do that is one of its greatest omissions is to add physical units of measure. And there's a language called Func that has every measurement known to man, and he is like the king of all measurement gurus. And that's where I got my fundamental constant values from, because he is actually now the curator for the entire world of those numbers. And but you can say 3 kilograms plus 2 pounds plus 3 ounces plus 1 gram in the syntax, because it has all the conversion factors of all the common physical units built into the compiler and runtime. So, and you can create your own units. So you can say, what's a furlong? A furlong is 220 yards. And then in your code, you can use a furlong from then on. I never use this. I built it for engineers, but engineers are very stubborn and they don't like to try new languages. So, but I did it anyway. And I think more people should add units of measure to their languages. I don't like regular expressions. So I tackled that and I said, let's take that regular expression that in JavaScript is one cryptic line, and let's break it into a vertical structure where you can have comments per section and use English words, keywords for boundary and how many, 1 plus quantity. So we made it easier to read, and you can actually understand someone's regular expression in this syntax. It generates the same exact final regular expression, but it's just it's a more readable notation that permits comments, and that is one of the better part. You know, it's a clever part of the programming language. This is where it really starts to diverge from almost every other language. There are no objects or RAM pointers in your program. So you have a tree system, you have a model in your code, and it is a hierarchical tree with crosslinks, and that is basically a sparse graph. It's a sparse n-dimensional matrix. which you can think of as a hierarchical tree with crosslinks. Anyway, the arrays can have numeric and string subscripts. That's the same as JavaScript, actually. Arrays have kind of a strange indexing system in JavaScript. And because we're not using memory pointers to an object, but rather a path from a starting point in the hierarchical structure, it is actually valid and can be saved onto the hard drive, loaded back, and sent across the network. And if you're sharing a subset of a tree of a database in the server, then you can actually have a valid pointer across machines. So that's something you do not see very often. Java, you can't send a pointer to another machine because it has no meaning, because it's a RAM address. There are no closures in these, but we achieve the same function by having what I call a frozen function call. And what you do is you save the parameter list with the address of the name of the function, and then later on you can call it. All right. No physical address, no closures. This is a big part of the language. 30%, a third of the language is related to drawing and layout. And this is where CSS is very weak. CSS has both an inside out and an outside in model that can be baffling, because if you put too much stuff in the middle of a block, it will push out all the other blocks around it and scramble your layout in a baffling way. This system we have is you are always subdividing from the outside in, so it is 100% consistent, repeatable, and there's no surprises. The other area where CSS, I think, blew it bad is they used implicit white space. So you say what your objects are, and then you tell it how to position them relative to each other, and then it tries to interpret your desires and then puts them out maybe in the way you want it. What we have is explicit white space. So we say, put this box and skip 3 points of space, and then put another box. And so you actually tell it how much space is in between the blocks, so that you are telling it always what you want exactly. And that way you get what you want. And this comes in very handy in mobile devices where you need real precision. Another area where drawing is a pain in the rear in the web is that oftentimes you have sizes specified, but depending on the kind of screen you're on, that size may be too big or too small. So what we have is you specify sizes as proportion of the height of the box, usually. And you can also have it, by default, it auto sizes. And if you overdo the text, it will shrink it down. So it's expensive, but boy, does it really pay off in when you're switching languages. German expands word length by about 20%. So you make it perfectly great, perfect in Svenska, and then you switch to Deutsch, and and all the words are spilling out of the boxes. So this is a handy little feature. Because I have this kind of directed graph as a tree, and that is your model, every node can have a value and children. And beyond that, there is a secret timestamp on each node of the tree. And the runtime is keeping track of when you have changed some aspect of your model. And this allows us to do something later on about refresh. Every time a drawing block is executed, the runtime is keeping track of what part of the model it looked at when it was drawing. So there's no other language that I'm aware of that does this. So this is a very intrusive thing. I'm actually saying every time I look at the model when I'm drawing, I'm going to remember what I looked at, and then 60 times a second, the runtime is seeing if the model has changed, that part of the model has changed that you looked at. Because if it has changed and you drew it, then you've got to be redrawn. So this is an automatic refresh that will guarantee that you sufficiently refresh the screen, and it approximates an optimal refresh. This avoids a whole class of bugs in graphical interactive software that I'm not aware of any other language addresses, which is, how do you know that you've redrawn enough of the screen? Now, in 3D graphics, you redraw the entire screen 60 or 120 times a second. That's because you have a GPU pounding on these graphics chips that does that for you. But that's not how the web is done. The web actually has a hierarchical textual representation of the screen that is then converted into pixels. And so when you change the document object model in the web, you have to emit basically character strings. And you should not change those character strings because it'll cause a re-render. So there's a lot of systems that re-render and then compare, but that actually is very, very inefficient. So this is a much more efficient way to do it. And when you get into client and server, we allow you to subscribe to a section of a model, and it will automatically transmit the any node that is changed in the model is sent in binary form across a communication channel automatically to the client. And when it's finally downloaded, it will then instantiate it on the client. So the client is always in a valid state, is updated as fast as it can be, and it does not have to do any message passing or encoding or decoding. Just a ton of JavaScript programs are constantly packing and unpacking JSON strings. We don't do any of that. You can do it, but it's obviously less reliable than letting the runtime do it for you. Now, does it work? Yes, it works well. And I'm going to show you some examples now of this is a mortgage calculator. Now, this is a very dumb application, right? This is something that's very simple. You're going to enter your price and your down payment and the rate and how many years, and then it's going to tell you how much your mortgage is. And you can add the taxes and fees. And this is typical for, a tiny house in California. Might be 500,000. The tiniest house, a shack. Anyway, this is on a regular screen. But if I click in Google Debugger to toggle the device, this is what it would look like on an iPhone 12 in portrait orientation. And if I click it on landscape, it flips it and it's still legible. So the idea of this code, the reason you would use beads is you want to be compatible with both mobile and desktop and tablet, and you want a simple notation, and you want it to look good on all those devices because it will stretch. Now, here is an example of a dynamic layout where I'm adjusting the window size, and the screen is going to rejuggle everything to fit. And it's going to fit as many as it can on the screen. And I specified a certain thing. Now, here I'm clicking on this column 2 box where it says A equals 10, and it's updating BB. So let me show you why. This is where the automatic update comes into play. If I go to the code, so remember we talked about how at the beginning of the code, you write your schema, you write your data, your model, and you say in a strongly typed language, what is the data types and structure of your model? In this case, I have three numbers, A, B, B, C, C, and a banner, which is a string, and that's my model. And I've declared a variable, the interface, which is gonna be of that type. And then main init is going to be called once in every program, and that is your one-time initialization program block. And then main draw, and that is the entry point. So what we're doing now is we're saying this block main draw, what kind of block is it? It's a vertical sliced block. So it's a columnar block where I am going to make blocks. I'm going to fill it with a blue color, and then I'm going to add the banner as a slice at the top. And it's going to be 30 points high. A point is 1/72 of an inch. It's about 1/3 of a millimeter. And that is it's a convenient number to do typographical things in. It's the long, for hundreds of years, it's been the standard in typography to use points because it's got enough precision for the human eye, but not too much precision. Anyway, and then I say add the remainder space, 10 aliquots. Aliquot is basically a proportion, and it's saying 10 units of proportion to the remainder. So what I've done is I've split the screen into two parts vertically. 30 points for the banner, where I'm going to say banner is here, and then the remainder is this lower section. So this is a domain-specific language where I'm adding slices to a box, and I'm subdividing the screen. And if I go to I have a 130-page user manual that you can, that I have on the Discord group. This is an example of the model. This is your data model. You have a node called C3, for example, that has 3 subnodes with values 11, 12, and 13. And then of 13 has children as well. This is different than Lisp and many other languages where your children do not have, you either have children or a value, but in beads, you can have both. And that allows you to go into subdivisions. And the subscripts can be both numeric or a string or a symbol, which is basically an enumerated number. Anyway, you do, and we have tree operations because now that you're operating with whole subtrees, you have kind of a different kind of assignment statement and so on. But back to the screen. Let's go back. Let's go back to another example. The color picker. This is an example of a color picker that I wrote, and you can download it and use it. And when you pick on a color, it copies the color name to the clipboard in any one of the 7 formats that people have asked for. If you were programming in C, you might want it as a hexadecimal number. And if you're programming in HTML, you want it with a pound sign in front and then 6 hex digits. And if you're doing 3D graphics, you might want it as a vec3 as an RGB fraction from 0 to 1. So this program, every time you pick a color in this middle section, it then goes to the bottom and shows you a few hundred of the nearby colors in the color cube. So this is a production, useful product that a lot of people use to pick colors. And it was written in beads, and it would be very difficult to write it shorter in another language because it's resizable. I can change the size of the screen and it will constantly readjust into a nice format. So it's always trying to be legible and good looking and fill available space efficiently. So it's trying to use all the space you give it and still be legible at all times. And that's why you would be interested in this language. Oh, I got to build something for the web, and I'm going to need to make it work on mobile and desktop and tablet, and I don't want to have 3 versions of my program, and I want it to be simple. That's why you would use this language. If you're not doing anything on the web, then this language will be of very little interest to you. Let's see if I can get to the dividing of the screen. Here we go. So in this case, in that test 1 program, the first thing I did is I have an undivided rectangle. The second step is I divided it into 2 slices by saying I take this thin sliver at the top and then I have a remainder. Then that remainder is subdivided into 3 vertical sections. So the way you build every layout is by taking this undivided rectangle and then continually subdividing it and doing that over and over again until you get down to the tiny part of the screen you actually want to draw something in, like a button or a chart or a number or some text. And that is how you proceed. And you do it by proportion. So you might say column 1, column 2, and column 3 are the same width. You don't say how big each column is. You just say they're proportionally relative to each other. And you can specify sum as an absolute size in points. And then it will first subtract that absolute dimension away from the available, and then subdivide what's ever left over. So let's go back to this test case. When I click on this 100-point button on the left, you can see the A, B, and C are being refreshed. So if I go to the source code for this code, and I look at column 1, and I see column 1, I'm drawing column 1, and I fill it with aquamarine. That's that light blue color. And then I say, draw it, and I convert the width from dots, pixels, into points. And then I say, at 30 points high, draw with a style S text. That's drawing that string 100 point. Then it says track EV tap. So when a user clicks or a mouse tap or a finger tap in a touchscreen environment, it's going to increment the interface A, B, and C variables. It does not schedule a redraw of anything else on the screen. It's just changing the model. But column 2, if we look at draw C21, it is drawing the value of AA. So last time it drew, it remembered that it used AA. And because someone has changed AA by tapping in this left column, now column 2, this block C21 is going to be redrawn. And in fact, it's going to redraw 3 different blocks based on this tap. Now, another advantage of this system is that if we look in the debugger, in the Chrome debugger, for the elements on the screen, and I say, okay, this is a div is a subdivision, right? And if I go into column 2, and I go and highlight this middle one, which says 28 right now, you can see that its ID is called draw underscore C22. Okay, so I go over to the code, draw C22. There is the block of code that drew that section. So this is giving you reverse mapping. You can see from the screen which part of the code drew it. And I got to tell you, that is not so easy to figure out in a lot of languages, especially TypeScript. TypeScript does nothing for you in this area. There's no help in reverse mapping in JavaScript or TypeScript. Because remember, TypeScript just compiles to plain JavaScript. So it's not helping you find the code that you're trying to fix. Like if I want to change this bottom block and I don't like that color, how do I know what code drew that? I can see from the Chrome debugger that this is draw C23. And if I go to C23 and I say, you know what, change that from dark orchid to black, right? And I say black and I save that. And then I go to the compiler and I say compile, and then I refresh my screen. Well, I didn't, I'm actually running on a different, hold on for a second. I was running off the web. There we go. Localhost. What did I do wrong? Oh, sorry. Did I not save it? I'm running off the wrong source code. Hold on for a second. I was downloading it on the web. Let me go back to the editor. C22, C23. Still dark Orchid. Okay. So I've changed it to black and I compiled it. And then if I go back to run it, there it is, it's black. So this allows you to build your product in small stages, incrementally, and you're always building on something sturdy. You start by declaring your schema, you initialize your data, you put in fake data, and then you start drawing the parts of your screen until you have it all drawn correctly. Then you get rid of the fake data and you take the real data made from the network or from user input. And you proceed in a very systematic way to build your product. And because you're only changing one tiny piece at a time and debugging it immediately, you will eventually get to a very sturdy final result. The other advantage of this syntax that, let's go back to the presentation. Can't find it. Okay. This system, by the way, the pattern that we're following in this language is the state action model pattern. You have a state, you do an action on it, and then you refresh it. That's the subdivision. That's the subdivision. Okay. We did this example. There's a real-time status monitor for the company I work for that is a client server product that I can show you the source code to, where we are checking every 30 seconds for the status of the 24 hardware nodes that we're running. We have 1,000 virtual machines running on 24 hardware nodes, and we want to make sure that those nodes are reachable because we have a backup, a hot spare running in a different city, and we want to know if things are still up. The percentage of punctuation, the readability of a language is very much determined by, in my opinion, by what percentage of punctuation you have. Perl is the worst. It has 39% punctuation. So if you take away the spaces and you compare alphabetic characters with punctuation, symbolic characters, Perl is the worst. And Perl has a reputation of being a write-only language. And Beads is absolutely down there in terms of low punctuation. And that is a virtue. If I go back to the code, you can see if you just scroll through it, and I can show you larger programs, this grid has 1 indent, 2 indent, 3 indent. That's the maximum. But the average nesting level of the code is under 2. If you do a numerical simple and you say, count up all the lines of code and measure what level of indenting is that code what level of nesting is that code resting at, you can see that by breaking your code into small chunks, which are in a hierarchy, but each code chunk tends to be, 3 or less in the nesting level. And that means overall, you're never going to be lost in a deep nesting. This was the drawback of Lisp, was the nesting level was super high. Anyway, I've run through this thing rather quickly, and and I'm hoping that the people who are interested in using this will contact me, and we'll make sure that you get the compiler and the documentation. I have a GitHub repository where I've posted most of this stuff, but the installation of this type of product is always a little tricky because Google does not, by default, does not allow you to load your own local JavaScript files. It actually blocks you from doing that. And it's bizarre that it does that, but you have to create a fake web server on your own machine to serve up your own JavaScript. Otherwise, it will say, oh, it's a security violation. So web development it's kind of perversely complicated. And I'm not sure why they want it to be that way, but that is the way it is. So I guess I will go to the Discord and, oh no, sorry, the Zoom, and go to the chat and see if there's any questions.
Thank you very much, Edward. Thank you very much for your interesting talk. Where can people find beads? Can we share some links, or should they contact you to get it?
No, it's on. If you go GitHub and you say beads language,
yeah,
you can find it. Let's see if I have. Let's see. That's. If you say GitHub.
Yeah, there you have it.
Beads language. Why does it say Kang? Oh, well, that's not going to work. All right.
Yeah, look, there it is.
Okay. And then there are many examples of, and there's the source code for the color picker. I recommend looking at that because I paid Mark Ferrari, who's one of the greatest pixel artists alive today, who did most of the LucasArts masterpieces. And he picked that color palette. And, I probably spent 1,500 euros on that. So it's worth studying just to see the colors and how he selected them.
Yep.
Anyway, yeah, that's where you can get most of the stuff. And like I said, the compiler, you have to, it is available for Macintosh, Windows, and Linux if you use Wine, which is the Windows emulator.
Okay. Next question from a guy in chat. Is beads indentation sensitive like Python?
Yes, it is.
Oh, okay. So will you auto format the code? I think Python does that for you today. You auto format the code to certain indentation to work, or
you can only use tabs and to indent. No spaces are allowed in the beginning of a line. So we ended the stupid Python battle of whether it's 4 spaces or 8 spaces or 2. And it's like, no, you have to use tabs, period.
Yeah.
So we guarantee 100% compatibility between people so they can share code. Because that drives people in Python crazy.
Oh, yes. Absolutely. Then let me see if there's more questions. Otherwise, thank you very much, Edward. And if you want to ask more questions to Edward or to Brooklyn about what they presented, please head over to the Discord server and you can ask.
Oh, I would like to say one thing before.
Yeah, sure.
Is that
do it?
I was an undergraduate at MIT in. I've been programming now for 54 years. I started when I was 16 on an IBM 1620 punchcard machine. And then I was at Jet Propulsion Lab and then CalTech. And then I went to undergrad at MIT. And I was working for this hotshot professor at the time. And because I was lucky, I got to attend a lecture by John Backus. Now, John Backus is not only the inventor of Fortran and a Turing Award winner, but he is the inventor of functional programming. And he presented his functional programming language in 1973. It was called Red. And he was at IBM Research Labs, and he was visiting all the universities around, the United States and possibly the world to present his new invention. And he gave an hour lecture, and I was in the lecture, and he told everybody that he was this new language, you would not be able to change a variable once you assigned it a value once. And the professors in the room at the end of the lecture came out shaking their heads, saying this man is a madman. And they absolutely hated the idea.
Yeah.
And functional programming, although he gave it a shot, it bounced off the wall hard and did not make a dent. But a few people in the academic circles embraced it, kept it alive, and have grown it into, to so large that you have a Swedish functional programming group.
Yes.
But the real intention of his, and if you read his Turing Award lecture, if you go back and read Backus's Turing Award lecture, which, by the way, they gave him a ton of crap about, because they thought it was an advertisement for his system, and they thought it was very crass and commercial of him to do that, to talk about his product, right? In his Turing Award lecture. You're supposed to just thank your peers, right? But here he was talking about his product. But the thing is, what he really wanted was interchangeable software components. He wanted to make Lego bricks out of code. And the problem that functional programming evolved into is it did not build interchangeable parts. And so this project, which I've already put 4,000 hours into, is trying to make code into Lego bricks. It's not graphical coding yet. It's still textual, but that we can address later in another generation of the language. But it is trying to make things out of small pieces of code that you could share with other people and that can still fit together, because the data model is very flexible. I'm not using tuples, arrays, lists, queues, and I don't have 22 data structures which are incompatible with each other. I only have one fundamental structure, this hierarchical tree with crosslinks, which means that everyone is sharing the same data structure. And I think that really we need to go back to Backus's original vision and try to get functional programming to what its goal was, which was interchangeable parts and simple. He was trying to make something simple and interchangeable, like Lego. I mean, Lego is the greatest construction toy that was ever invented. It's almost 100 years old now, and it's still the world's best construction toy. Every kid loves it in every country on earth. And there's museums, amusement parks. What other construction toy has an amusement park devoted to it? None. Okay. And actually, there's multiple Legolands, right? So we need to simplify programming, and that was my effort in this. And I know that this looks kind of simplistic and dumb to you, but it is trying to simplify things. Because if we don't simplify things, we're going to collapse from the weight of all of these abstractions that we built. And so that's my hopefully amusing anecdote about the great John Backus.
Thank you very much, Edward. Thank you very much. And also, I never heard of Backus, so I will check him up. And also the red language, I never heard of that, so I'll Google it away and try to find some more information about it. So
just look at his Turing Award lecture.
Yeah,
and you'll hear about it.
will do. Thank you, Edward, and thank you everyone for joining tonight. Thanks to both presenters and everyone joining and looking at us live. For those who would like to ask more questions or have thoughts, want to share stuff, get onto Discord, the Discord server, and you can join and share your thoughts or ask more questions to both of the presenters. So with that, thank you very much, and good morning, good afternoon, or good evening to wherever you are in the world. Bye for now.